In today's lesson, we want to look at working and simplifying with radicals. So let's take a look at our first example here. Whenever being asked to simplify radicals, the first thing we should do is write everything in exponential form. Writing this first question in exponential form we get. And you can see here we were taking the third root of each expression, the numerator and denominator. So I went ahead and wrote this in exponential form. I'm now going to distribute that exponent of a third to each of these terms, both on the top and on the bottom, and that will give us the following. And we can see here I went ahead and distributed that a third to each one of these. You'll notice when the third was multiplied by y to the 3, we just got a y left over. Now we want to go ahead and simplify a bit. You'll notice that we have 40 to the power of a third and 8 to the power of a third. We can put that together and express that as 40 over 8 to the power of a third. And the x to the power of a thirds completely cancel, leaving us with y to the power of a third. And you'll see here 40 over 8 is 5, so I can write that as 5 to the third times y to the third, which again, we can put that back together as 5y to the power of a third. So our answer is the third root of 5y. All right, let's take a look at the next example. So in the next example here, we want to evaluate the following expression. First thing we should do here is notice we have a difference of cubes going on the top. So I'm going to go ahead and apply the difference of cubes, giving us the following. And you'll notice here I applied my difference of cubes formula. I'm now going to separate the root. I'm going to write this as the root of x minus y times the root of x squared plus xy plus y squared. And you can see here by applying that root separately, we now have cancellation. And you can see here by separating those two, we have cancellation in the root of x minus y. And our final answer becomes the square root of x squared plus xy plus y squared. And now let's take a look at the next set of examples. So the next two examples here, again, let's focus our attention on this first one here. I want to reduce this and simplify it. So first thing to do here is notice we have the negative exponent law that happens. I've got here an expression to the negative a half. So you know using the negative exponent law, which if you recall, what the negative exponent law says is if you have an expression, let's say x over y to the power of negative k, some exponent, we can re-express that as y over x and drop that minus sign. So I'm going to go ahead and do that first, giving us. Now that I have gotten rid of the negative exponent, I'm going to distribute this a half to both the terms on the top and on the bottom, giving us. And you can see I went ahead and distributed that exponent. So now we have 4 to the half is just the square root of 4, which is 2. The y to the negative 1 I got by taking the half times negative 2 is negative 1, and we'll leave it in that form. And now for the bottom here, we have 2/3 times 1/2 is going to become x to the power of a third. And now if we want to fully simplify this expression, we can now use that negative exponent law again, and that'll push this expression, the y, to the bottom. This will end up being 2 over x to the third y, and then go back to radical notation. It'll be 2 times y to the third root of x. All right, let's take a look at the next question here. We want to simplify the following. So again, always go to exponential form. I'm going to go ahead and everywhere I see here, I have a square root function here. I'll change that to exponent of a half. We put our a cubed back down. This is multiplication operation between these two. This right here is the third root of a squared, which I can write as a to the power of 3/2. And again, that whole thing was being taken the square root of. So applying your BEDMAS rules, you want to go ahead and take care of brackets first. We're multiplying with the same base. We can add these exponents. This ends up being a to what power? This becomes a to the power of 9 over 2. And the whole thing raised to the power of a half. And you'll notice here that now we have power to a power, 9/2 to the power of 1/2. Power to a power, we multiply. This becomes a to the power of 9 over 4. And now it is simplified. All right, let's take a look at the next example here. So for this example, again, we want to simplify the following expression. Write everything in exponential form. Doing so, we get. All right, going ahead and writing this all in exponential form, you see I got rid of the fourth root, changed it to a quarter, got rid of the third root, changed it to a third, got rid of the square root, changed it to a half. We now have power to a power. We can multiply here. So with power to a power, we have 2 times a quarter, which giving us x plus y to the power of a half. Then I have my x plus y to the power of a third, taking that entire expression, and again we have power to a power. this becomes x plus y, and that's the power of 3/2. So now we're multiplying with the same base, and when you multiply with the same base, you can go ahead and add the exponents. Adding the exponents here, we end up getting x plus y to the power of 1/2 plus a third, and 1/2 plus a third. If you take a look here, if I take 1/2 and add a third to that, you end up getting 3 plus 2 over 6, which ends up giving you 5 over 6. So this becomes to the power of 5 over 6, and on the bottom it's x plus y to the 3/2. Now we are dividing with the same base, you'll see here, so I want to subtract the exponents. So now we're going to take 5 over 6 minus 3 over 2, which is 5 over 6 minus 9 over 6. Again, just multiplying top and bottom by 3, giving us 4 over 6, or equivalently minus 2/3. So this will end up being x plus y to the exponent of minus 2/3. And we have our simplified answer. So in the next examples here, same idea, we want to reduce this down. So right away with this question here, I'm going to write this as, because this is a square root, we're taking to the exponent of 1/2. I'm going to go ahead and write this as 5 squared, b to the power of 3, and I'm going to rewrite that 121 as 11 squared, a to the power of 4, and I'm raising this entire expression to the power of 1/2. So now when I distribute my exponent into the top and the bottom, don't forget the bottom, we end up getting here, when you distribute to the 5 squared, you just get 5. When I distribute to the b cubed, it becomes b to the 3/2. When I distribute to the 11 squared, you see here it's going to distribute the 11 squared, you just get 11. And lastly, when I distribute to the a to the power of 4, you get 8 squared. So this ends up being 5 over 11, b to the 3/2 over a squared. If you look at b to the 3/2, that is equal to b cubed to the power of 1/2, which is b squared times b to the power of 1/2, which is going to end up being b times b to the power of 1/2. So it's b root b is what you get here. Again, we're assuming the variables a and b, x and y, all the ones we've used here are positive variables, so I do not need an absolute value on this. We'll just assume it is b root b. So we can change that. This will become 5b root b over 11a squared. And that can be our simplified expression. All right, let's take a look at the next example here. So for the next example here, again, go right to exponential form. That's what you want to do. This is going to be 2 times ax squared, raise that to the power of a third, plus 5, and then put your brackets. That's 27x squared, again raised to the power of a third. Lastly, minus 3 times x cubed, again raised to the power of a third. Apply this one by one here. So the 2 is out front. That's going to be written down again. The third gets applied to the 8. Essentially asking for the cube root of 8, which is 2, and then next to the 2/3. Again, the 5 out front. The 27 we're taking the third root of, which is 3. And again, you get your x to the 2/3. And that minus 3 is out in front, and this becomes x to the power of 3 times the third is just x. So simplifying this up a bit, we get 4x to the 2/3 plus 15x to the 2/3 minus 3x. And you can see here, these are now like terms. You have 4 of these x to the 2/3 and adding another 15 of these x to the 2/3. So you end up getting 19x to the 2/3 minus 3x. And that becomes our simplified expression. Let's take a look at another example. In the next example here, same idea. We want to go right to exponential form. So I'm going to go ahead and do that. I'm going to take the xy squared and write it as xy squared to the power of 1/2. I'll take that root here, and this will be 9ab, again to the power of 1/2, divided by 3, again putting that to the power of 1/2, and likewise for the last term here. So now it's just a matter of tackling each of these individually and kind of expanding out that exponential. So this is going to be 4 x to the half y. Right, again, we're multiplying here, so x to the half, so that exponent on the x is a 1, gives you x to the half, and then y squared times a half, so 2 times a half is 1. Again, this half will be now distributed to the 9, giving us 3. This will be a to the half times b to the half. Divide the whole thing out. 3 goes out in front. This becomes x to the negative a half, y to the negative 1. The square root of 16 is 4. This becomes a to the minus 5 halves times b to the minus 1 half. So continuing here, we want to simplify this. You'll notice the 3's cancel and the 4's cancel, which is nice. Now you're dividing with the same base for a lot of these, so we're going to divide out our x's. And we're dividing our x's out with the exact same base, so we're going to subtract the exponents. In which case here you'll notice we're going to end up getting a half minus a half is going to be x to the power of 1. Then again for the next sequence here we're dividing with the same base. And for the next chunk here you'll see we both have a base of y this time. The exponent on this y is a 1. So now we are subtracting. This becomes 1 minus negative 1 becomes y to the power of 2. And moving on to the a's here, we end up getting again same base. And we're going to go ahead and subtract the exponent. So 1 half minus 5 over 2. So 1 half minus 5 over 2 is 6 over 2, which is 3. This becomes a cubed. And lastly, again, same base. Subtracting the exponents of 1 half minus negative a half becomes 1 half minus negative half is 1. And this just becomes a variable of b. So simplifying this up and wrapping this up, this is xy squared a cubed times b. And now we have our expression fully simplified. Let's take a look at the next example. So in the next and final example here, we want to go ahead and simplify this expression. Right away, you'll notice that in this example here, we have a common factor of the root of a plus b. And if you don't see that, notice that we can rewrite one of these expressions. So if I have here a plus b cubed can be written as a plus b times a plus b squared. And therefore, if we take the square root of both sides of these, you have this expression being equivalent. But you can break up your square roots. So this can be broken up into the square root of a plus b times the square root of a plus b, the entire expression squared. So let's go ahead and do that and substitute that into our original equation here, giving us the following. So you'll notice here I went ahead and did that, and now we have a common factor of the square root of a plus b present in all three terms. So I can go ahead and factor that out of the expression, giving us. And you'll notice here I factor that root of a plus b, leaving us with the following. I also simplified this, the square root of a plus b quantity squared. I just wrote as a plus b. And again, we're assuming a and b are positive, so I can drop the absolute value on that. Now I'm going to go ahead and distribute and simplify, giving us. And you can see here I went ahead and distributed. We end up getting this expression. In terms of simplifying, we can see this simplifies to become 5a squared. And the 5ab cancel off with a minus 2ab minus 3ab, leaving us with just a minus 3b squared. And now we have our fully simplified expression. And you can see here, so with a bit of observation, you can see this complicated expression here ended up simplifying to the following. All right, that concludes today's lesson on working with radicals and simplifying them. Thank you.